Hi there, we're going to continue finding inverses of functions. So this is part 2 of the previous video. In the previous one, we found the inverse for a nice linear function. In this video, we're going to find the inverse for this one. F of x is x over x minus 2. And so I just outlined some of the steps in finding the inverses. So the first thing is let f of x equals y. So you change, and whether that's f of x or g of x or h of x, whatever the name of the function is, you just kind of change it to y. Then step 2 is change or switch your x's and your y's, and then solve for y. And then that new y that you found is your f inverse or g inverse or h inverse, whatever the name of the function is. So let's start with the first step. So we want to let f of x be y. So the first thing is we're going to say y is equal to x over is x minus 2. So we changed our function name to y. The second step, it says switch your x and your y's. So from here, we're going to go to step 2, switch the x and the y. So that means that what was a y is now an x, and what were x's are now y's. So I have y over y minus 2. And the third step is to solve for y. And so this is where things are not so nice because it's not linear. So let's solve for y here. And how do I solve for y? Let's multiply both sides by y minus 2 to clear the denominators, or you can think about it cross multiplying. So I'm going to have, so multiply both sides by y minus 2 so that I can get rid of it. So I'm going to be left with x times y minus 2 equals y. And remember, my goal is to solve for y, so I want to isolate the y. So that means get rid of this parenthesis here because I want to get to the y. So xy minus 2x equals y. So now I have y on the left side and y on the right. In order to solve for y, I need to isolate y on one side. Then I need the y's on the same side. So let me move things around. So we're going to subtract the y from the right, and we're going to add the 2x. I'm going to do it in one step. So those cancel, so I'm left with xy minus y on the left equals 2x. And if you need to do a step by step, subtract the y first and then add the 2x, then that's fine. But the goal is to get the y's on the same side. Now notice I have two terms. Both of those terms have a y in it, so I can factor the y out, and I'm left with x minus 1 equals 2x. And now I can get y by itself. Remember, the goal is to solve for y, get y alone, so divide both sides by x minus 1. And so I get that y is equal to then 2x over x minus 1. So this is my f inverse. So now the fourth step is to just rename your y f inverse of x, or g inverse of a, or h inverse, whatever the name of your original function was. Now the domain of this function, the domain of the inverse, is x can't be 1. So all real numbers except 1. So that means minus infinity to 1, union 1 to infinity. Now remember that the inverse was taking the outputs and putting them as inputs. So what this also says is that this range of values is actually the range of the original function. So the domain of f inverse is the range of the original f of x. And so that's pretty cool because up to now, we've only been able to find the domain of a function. But by finding the inverse, now I know, oh, the domain of the inverse is the range of the function of f of x. So going back to my function, what was the original function? X over x minus 2. So here, So for f of x equals x over x minus 2, now I can state the domain and the range for f of x. Notice that the domain of f is x cannot be 2, so that means minus infinity to 2, not including 2, and then 2 to infinity. Now the range, there would have been no way for me to know the range just by looking at the function. I will have to maybe look at the graph of it, but now thanks to the inverse, I know that the range of f of x is the domain of the inverse. So the range of f of x then is minus infinity to 1 union 1 to infinity from up here. The range of the inverse, the domain of the inverse, sorry. Okay, so let's try another example. So let f of x be x squared minus 2x, 4x is greater than or equal to 1. Let's find f inverse of x. So remember we said that a function has to be 1 to 1 for it to have an inverse. When you see a quadratic, remember a quadratic is a parabola. So a parabola is not going to pass the horizontal line test of being 1 to 1. But that's why we have this part here that says for x greater than or equal to 1. So what this means is that then the function f of x is 1 to 1 in this portion. So let's look at what the graph of that looks like. So this is the graph of f of x, and notice that when x is equal to 1, that's where the vertex happens. So this is the line of symmetry. So a vertex, if you truncate it at the line of symmetry, then half of it will be 1 to 1. So for our purpose, x is greater than or equal to 1 means this part of the graph is what we want. And so notice that if you're just considering the highlighted part, this will pass the horizontal line test. So it is 1 to 1. So this is 1 to 1 for x greater or equal to 1. We could also truncate it the other way to say x is less than 1, and then the other half would have been 1 to 1. It's just that together is not 1 to 1. So this normally wouldn't have an inverse, but when we truncate it, then it does have an inverse. So how do we find the inverse? So let's go back and follow the steps. So one is call it y. So y equals x squared minus 2x. 2, change your x and your y's. So anything, so I'm going to, y becomes an x and all the x's become y's. And now here, we're a little bit of a pickle, right? How do you isolate the y? So my goal is to solve for y, which means isolate it. But one is square and the other one is not. So how do I solve it? It is a quadratic, but I don't want to set it equal to 0 because I don't want to have my x's and my y's mixed up. So this is where we're going to complete the square. Back in chapter 1, we reviewed how to complete the square, and that comes in handy in these types of problems. So I'm going to have x equals then y squared minus 2y, and completing the square is we take the coefficient of the linear term, right, of the y. So I'm going to take the minus 2 divided by 2, take half of it, right, you get negative 1, and then you square it. Negative 1 squared is 1, so that's what we add to both sides, and that completes the square. So adding it to both sides, I end up with x plus 1 on the right equals y squared minus 2y plus 1 on the left, or on the right. And so I have x plus 1 equals, the whole point of completing the square is so that this factors into a perfect square. Which perfect square? Y minus 1. Right, what two numbers multiply to positive 1 and add up to negative 2. So y minus 1 squared. And now I can solve for y. So isolate the y, So in this case, get rid of the square, which means take the square root of both sides. But anytime you take the square root, you get plus or minus. So I'm going to get plus or minus the square root of x plus 1. And so normally this would be a red flag. It's like, whoa, wait a minute. I can't get a plus or minus because for the inverse, an output is only allowed to have one input. So this plus or minus will normally be a red flag, except that we truncated the graph. So when x is greater or equal to 1. And so to see which one we would need is, well, let's look at the points on the graph. So this is the point, it appears to be the point 2, 0. So remember, this is my xy. So in the inverse, it becomes yx. So that will be 0, 2. So it will be up here. So it will be essentially the positive side. So this, for the inverse, because for x is greater than 1, we're going to take the positive side. So I'm going to say positive square root of x plus 1 is equal to y minus 1. And then add 1 to both sides. I'm going to have y is equal to the square root of x plus 1 and then plus 1. Now notice that this is under the square root, whereas that plus 1 is not. So don't make the mistake of saying x plus 2, right? Those are not like terms. This is not under a radical, and that one is plus. You can't, properties of radicals don't allow you to add things from two different radicals like that. So this will be our inverse. So I can say then f inverse of x is equal to the square root of x plus 1 plus 1. So that will be our inverse. Okay, so anytime that you see a function like this, especially if it has an even power, you should see something that says for x greater than something, than a value, or less than, because that means it's a likely parabola and you're truncating it, or it's a function that normally wouldn't be one-to-one, and so you're truncating the domain so that it is one-to-one. So another place that you might see something like this will be an absolute value function, because as we saw in the previous video, absolute value functions are not one-to-one, and so you will have to truncate it at the axis of symmetry. Usually it's at the axis of symmetry for functions to be one-to-one. So a function, again, just to restate it, a function is one-to-one. A function that is one-to-one has an inverse. So if a function is not one-to-one, it doesn't have an inverse.